Hello everyone. Today we are going to calculate the problem number 6 from the fundamental problems. It's from the RChibbeler Static and Dynamic book 14th edition. So we will start looking at the given facts. So for a short period of time, the motor turns gear A with a constant angular acceleration. Looking at this given fact, we can use the equation 16.567, and it also said it's starting from rest, so that means the angular velocity initial position is 0. So the problem asks us to determine the velocity of cylinder and distance it travels in 3 seconds. So it asks about velocity and distance in which is v and s in 3 seconds. And we'll write down here the given facts. So it's alpha A equal to 4.5 radian per second square. And starting from rest, that's why it's omega naught A, it's 0. And the given facts, it's gear A and gear B has these are distance are A 75 millimeter, which is equal to 0.075 meter, and B is equal to 5 millimeter, and is equal to 0.225 meter, and RD is also given here in the picture, is equal to 125 millimeter, and it's equal to 0.125 meter, and the given time t is 3 seconds. So from these given facts, we can find, we have the known information about the gear A. So from these facts, we can find the acceleration in the interchangeable component of point gear A. So it's TA. It's alpha A RA equal to 4.5 radian per second square into 0.075 meter. So it's ATA is equal to 0.338 meter per second square. And looking at this picture, this gear A and gear B is rotating at the same acceleration in tangential component. So we will write down the acceleration and tangential position of gear B is also equal to acceleration and tangential component of A equals 0.338 meter per second square. And from this point forward, from this A in tangential component, we can find the alpha acceleration, angular acceleration. So it's alpha B and RB equal to 0.338. And that is why we have this alpha B value 0.338 meter per second square by 0.225 meter. So it's equal to 1.502 radian per second square. From this information of alpha B, we can find the omega B and theta B of gear B. So we will use the equation 16.5 as always. So equation 16.5 is omega B equal to omega naught B plus alpha B equal to T. So from this given facts, we have known the initial position at rest of gear A, but if the gear A is at rest, the gear B is also at rest. So that's why we will put initial position of gear B, it's at 0. So it's omega B, it's equal to 0 plus 1.502 radian per second square into 3 seconds as this problem is required. So it's omega b is equal to 4.506 radian per second. So omega b, and again we can use the equation 16.6 to find out the angular position of gear B, and B naught is equal to omega naught B into T plus 1 by 2 alpha B T squared. So it's equal to omega B, its initial position is 0 and T is 3 seconds, so and then 1 by 2 alpha B is 1.502 into 3 seconds. So this is 0. That's why B equal to 6.759 radian. And we have this angular velocity and angular position, so we can find the magnitude of for the speed vc. The problem asks for the cylinder, but the cylinder is connected by this string or belt, and that's why we can use the same VB and angular position as the same. That's why VC is equal to VB, and from VB we can find from omega B. So it's omega B into RB, and it's 4.506 into I'll write down the units as well, and then 0.225 meter is equal to 1.014 meter per second. And then X cylinder is also DRP, and then RD is because this string is connected in this D distance, so it's 6.759 radian per radian, and then 0.125 meter, so it came out as 0.845 meter. So now we got this answer as required for the cylinder velocity and distance traveled in 3 seconds. So there's only one thing to be aware of. In finding the distance, we need to use RD value, which is not RB value, because it is connected by the inner D plate here. So yes, thank you.